Hello dear, how are you all? Today in this video we will solve exercise 1.4 Fsc Mathematics part 2. Question 2. Check the continuity at x is equal to. If any function continues at any given point, then there are three axioms. First of all, function must be defined at given point. Second, limit exists at that point. Third, limiting value will be equal to function value. To check continuity, first we check whether function is defined or not at x is equal to. First of all, we put x is equal to in given function to check that function is defined or not. Suppose when x is equal to, when x is equal to 2, we put here x is equal to 2, we get 2 multiplied 2 plus 5, which is 9. This implies that function is defined. Why 9 is the value of function at x is equal to, function is defined at x is equal to. First axiom is satisfied, function is defined at x is equal to 2. We now find the limit of function at x is equal to. We check both limits, left hand limit and right hand limit. We write limit of function when x approaches to, from lower value of 2 toward 2, or I mean to say we take left hand limit and we take right hand limit of function. For left hand limit, we know x approaches to 2 being x approaches to 2 from smaller value of 2 to. We write x approaches to 2. For x approaches to 2, for left hand limit, function will be 2x plus 5. And for right hand limit, we choose function 4x plus 1. For left hand limit, when we put x equal to, when we put x is equal to 2, or we replace x by 2, we will get 2 multiplied 2 plus 5, and here 4 multiplied 2 plus 1, 9 is equal to 9. It means left hand limit will be equal to right hand limit. When left hand limit and right hand limit both are equal, it means limit exists. Limit of function when x approaches to 2 exists. We write limit of function when x approaches to 2 exists. And limiting value in both cases 9. Limit of function exists. You know function value also 9 and limiting value also 9. We can say that function is continuous when x approaches to 2. Our function is continuous at x is equal to 2 because function is defined at x is equal to, limit exists when x approaches to 2, and function value will be equal to limiting value. We write limiting value is equal to function value. Functional value. Both values are equal because functional value, limiting value is equal to 9, function value is equal to 9. Hence function is continuous. Hence function is continuous. continuous at x equal to. In second part of this question, in second part, function is f of x is equal to 3x minus 1, 4 and 2x. If x less than 1, function will be 3x minus 1. If x exact is equal to 1, function value will be 4. And when x is greater than 1, function is 2x. We have to check the continuity at x equal to 1. Check the continuity at x is equal to 1. Now, in second part of question 2, we have to check the continuity at x is equal to 1. We first check whether function is defined or not x is equal to 1. We write f of 1. When x is equal to 1, it is given that function value will be equal to 4. Given. It is given that when x is equal to 1, function value is 4. It means function is defined at x is equal to 4. We write function is defined at x is equal to 1. First axiom is satisfied. Function is defined at x is 1. We will find limit, right hand limit and left hand limit. Limit of function x approaches to 1 for left hand limit will be equal to right hand limit if function is continuous. For left hand limit, you know x will be approaching to 1 from lower value of 1. For this limit, function will be 3x minus 1. We write x minus 1 limit of, for right hand limit we choose function 2x. We will put or we will replace x is equal to 1 on both sides. Is equal to, which means left hand limit is equal to right hand limit. It means left hand limit is equal to right hand limit means limit exists. Since both answers are equal, hence we can say that limit exists. We write limit of function when x approaches to 1 exists. Its limit exists. Now function value which is 4 but limiting value which is 2. You note function value is not equal to limiting value. We write function value is not equal to limiting value. Hence, since limiting value and function value are not equal, we can say that function is not continuous. Function is not continuous or discontinuous. Function is not continuous. At x equal to 1. Function is not continuous at x equal to 1. Third part, question number 3. In question 3, In question 3, given function is f of x is equal to 3x when x less than equal to minus 2, x square minus 1 if x less than 2 greater than minus 2, and function value is 3 if x greater than equal to 2. Check the continuity. Given that, check the continuity. And x is equal to minus 2. Check the continuity at x equal to 2 and x equal to minus 2. First we take x equal to 2. We take x is equal to 2. We will check whether function is defined or not when x is equal to 2. We put f of 2. Function value will be function value when x is equal to exact 2, the function value is given 3. It means function is defined. This is the function value. And it is given. Hence function is defined. Function is defined. Function is defined at x is equal to 2. When function is defined, we will find limit, right hand limit and left hand limit. When x approaches to 2, limit. We find left hand limit and right hand limit. For left hand limit, we choose f of x less than 2, which less than 2 means we take function x square minus 1. X square minus 1. And for right hand limit, function value 3. When we place x equal to square of 2 minus 2 and limit of any constant is equal to constant 4 minus 1, 3 is equal to 3 means left hand limit is equal to right hand limit. Left hand limit is equal to right hand limit. So both limits give same answer. We write limit exists. Limit of function when x approaches to 1 exists. Limit of function exists. We will check function value and limiting value. Function value will be 3 and limiting value also will be equal to 3. We write limiting value is equal to function value. Hence, function is continuous at x is equal to. Function is continuous at x is equal to. We will check whether function is continuous at x equal to minus 2. When we take x is equal to minus 2, we to take x is equal to minus 2. We take x is equal to minus 2. When we take x is equal to minus 2, we find the function value at x equal minus 2, f of minus 2. F of minus 2 we replace x equal minus 2 in the function f of x equal 3x minus 6. It means function value exists when x equal minus 2, function value is minus 6, function is defined at x equal minus 6. Function is defined. This is the function value. These are function value. Function is defined. This implies that function is defined. We will find limit. X approaches to minus 2 from left side. Minus 2 from right side. The function for left hand limit, x approaches to minus 2 from lower value of 2, we take x square minus 1. Function will be x square minus 1. For the right hand limit, when x approaches to minus 2 from higher value of 2, we take the function is 3. We now replace x equal minus 2, square of minus 2, minus 1, limit of any constant is constant itself 3, 4 minus 1 is equal to 3 and 3 is equal to 3. It means limit exists. Left hand limit is equal to right hand limit. Is equal to right hand limit. Right hand limit. It means limit exists. Limit of function. Limit of function when x approaches to minus 2 exists. Here limit also exists, but function value which is minus 6 and limiting value which is 3, both are not equal. We write limiting value is not equal to function value. Hence function is not continuous. At x is equal to minus 2. At x is equal to minus 2, function is not continuous. We will solve question 4. In question 4, we have to find the value of c. In question 4, it is given that question 4. In question 4, given function is f of x is equal to x plus 2 and x less than equal to minus 1 and f of x is equal to c plus 2 when x greater than minus 1. Find c so that limit exists. Find c so that limit of function when x approaches to 1 exists. So x approaches to minus 1 when x approaches to minus 1. In this question we don't need to prove function is continuous, but it is given that limit of function exists. It is given that limit of function exists. It means the right hand limit and left hand limit both will be equal when x approaches to minus 1. And from this we have to find the value of constant unknown c. Since limit exists, we write left hand limit. Left hand limit of function will be equal to right hand limit. Why did we write these both limits, left hand limit and right hand limit? Why these limits are equal? Because it is given that limit exists, so we can write left hand limit and right hand limit both will be equal. From this we have to find the value of constant. For left hand limit we choose the function left hand. For left hand we write function x plus 2, and for right hand limit we choose c plus 2. We apply the limit minus 1 plus 2 is equal to limit of any constant is itself constant. 1 is equal to c plus 2 and c is equal to minus 1. So this is the value of c is equal to minus 1. For this value of c is equal to minus 1, limit of function exists. Thank you.